Okay, so let's work this series circuit together. The first thing we have to do is find the totals. We need our voltage total, our resistance total, and our current total. Okay? Voltage total is easy. It's given to us. 6 volts. Resistance total is sitting here. We've got resistance at each of our resistors. So on a series circuit, we sum. So our resistance is going to be 10 ohms plus 20 ohms plus 30 ohms, which gives us 60 ohms for our resistance total on the entire circuit. Finally, we need our current. We're given 2 variables. We need a third. Pretty easy. Let's go to our triangle. Ver. We're looking for current. So it's going to be V over R. V1 over R1, which happens to equal 6 volts over 60 ohms, or 0.1 amps. Okay, we've got our totals. I'm going to write them over here for now so we have some space. And I'll erase this area so I can reuse it. We've got our totals. The second thing we want to do is get the values for each of the points on our circuit, each resistor point. I generally number mine like, do this. Number them from left to clockwise, okay? 2, 3. If you're not given the numbers, just number them clockwise. We've got our ohms at each location, 1, 2, and 3. We've got to remember this mnemonic. Current, which is an I, okay, is the same in series. If you remember this mnemonic, you'll be in good shape, because what we've got is current is the same. Or we could look at it this way. IS is. Current is the same in a series circuit. Good. That being the case, I've already got my current listed over here. So it's 0.1 amps, 0.1 amps, and 0.1 amps. Quick and easy there. This means all that's left to do at each of these locations is to find our voltage. I'm going to come over here, and for each of our resistors, I'll write down that we've got I1 equals 0.1 amps. R1 equals 10 ohms. I2 equals 0.1 amps. R2 equals 20 ohms. I3, 3 equals 0, because it's the same for all of them. And R3 equals 30 ohms. All we need now is the voltage. Again, we look to our triangle. Ver. This time we're looking for voltage, so we're going to be multiplying the current and resistance. Pretty quick and easy. Voltage 1 equals I1 times R1, or 0.1 times 10, which happens to equal 1 volt. R2 is going to be the same, or excuse me, not R2, voltage on 2 is going to be I1 times 2 times R2, which equals 0.1 times 20. Let me do it this way so it's easier to see. Equals 2 volts. V3 equals I3 times R3, which equals 0.1 times 30, which equals 3 volts. So we think we've got everything here. What we want to do is double check and make sure we're correct. So we always check our work with Kirchhoff's laws, because the thing that changes in a series is our voltage. We use Kirchhoff's voltage law, which is, or Kirchhoff, I don't know. Anyway, which is 1 volt. We sum the volts. 1 volt plus 2 volts plus 3 volts, which equals 6 volts. This matches our total voltage. So we're good. We have solved for the entire circuit. In the end, what you generally want to do is write all this down. Oops. At each point. So I would have I1 equals 0.1 amps. I2 equals 0.1 amps. I3 equals 0.1 amps. And then V1 equals 1 volt. V2 equals 2 volts. Let me clear off a little space here. V3 equals 3 volts. Clear off some more space. And on our diagram for totals, we would write RT equals 60 ohms and IT equals 0.1 amps. It's not real neat in there, but you can see the process. Hopefully this helps you understand how to solve a series circuit. They're all basically the same. Okay?